Hello, today we will be differentiating inverse trigonometric functions. So there are 6 formulas which you should know. The 6 inverse trigonometric functions are sine inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. In LaTeX language it is written CAC only, but here we in our books we find this as COSEC, that is cosec. So please note down these 6 formulas, then we will proceed. Question number 1, cos inverse of 2x. So let y equals to cos inverse of 2x, differentiating both sides with respect to x. We will consider this 2x as single x, then it will be ddx of cos inverse x, and for that the formula is minus 1 over root over 1 minus x square, but here it is 2x whole square, into ddx of 2x by chain rule. So this will be equal to, now here ddx of 2x is simply 2, so my answer will be minus 2 over root over 1 minus 4x square. Question number 2, sine inverse of cos x. So let y equals to sine inverse of cos x. So inside sine inverse there is cos x. Therefore dy over dx will be equal to ddx of sine inverse of cos x. We will consider this cos x as simply x. Then ddx of sine inverse x is 1 over root over 1 minus x square, but here it is cos square, so we will have cos square x, but we have to differentiate the cos x, that is ddx of cos x. Hence my answer will be minus sine x over square root of 1 minus cos square x. Number 3, let y equals to e to the power tan inverse of root x. Therefore ddx of y will be equal to ddx of e to the power tan inverse of root x. So for now we will consider tan inverse root x as x, then it will be ddx of e to the power x, and we know that differentiation of e to the power x is e to the power x only, so it will be e to the power tan inverse of root x, but we have to differentiate this tan inverse of root x also. So it will be equal to e to the power tan inverse of root x into, here for now we will consider again this root x as simply x, then ddx of tan inverse x is 1 by 1 plus x square. So here it will be root x whole square, and again we have to differentiate root over x. So it will be equal to e to the power tan inverse of root x into 1 over 1 plus x into ddx of root x is 1 by 2 root x. Rearranging, we will have e to the power tan inverse of root x at numerator and 2 root x into 1 plus x at denominator. Question number 4, let y equals to square root of sine inverse of x square. Differentiating both sides with respect to x, then we will have ddx of root over sine inverse of x square. Considering sine inverse x square as x, this is ddx of root x, then we will have 1 by 2 root x, that is 1 by 2 root over sine inverse of x square into ddx of sine inverse x square. Again considering this x square as x, we will have 1 by 2 root over sine inverse of x square into ddx of sine inverse x is 1 by square root of 1 minus x square. So here it will be x square square and ddx of x square. So it will be 1 by 2 root over sine inverse of x square into 1 over root under 1 minus x to the power 4 into ddx of x square is 2x. So this 2 and 2 gets cancelled. So hence we will have x at numerator and root over sine inverse of x square into root over 1 minus x to the power 4 in denominator. Question number 5. Let y equals to cot inverse x square whole cube. Therefore, dy over dx will be ddx of cot inverse x square whole cube. Considering this everything as x, then we will have ddx of x cube, and differentiation of x cube is 3x square, so we will have 3x square into ddx of cot inverse x square. Now again we will consider this x square as x, then we will have 3 cot inverse x square whole square into ddx of cot inverse x is minus 1 by 1 plus x square whole square into ddx of x square. So here it will be minus 3 cot inverse x square whole divided by 1 plus x to the power 4 into 2x. So it will be minus 6x cot inverse x square whole divided by 1 plus x to the power 4. The last question of this video, differentiating both sides with respect to x, then we will have dy over dx equals to, we can distribute the differentiation, then we will have ddx of 2x tan inverse of x minus ddx of log of 1 plus x square. So here in the first term, there are two functions getting multiplied, that is x and tan inverse x. So here we will be using product rule. And on the second term, we have log of 1 plus x square. We will consider everything this as x. So since 2 is constant, so in the first term, so we will write 2 at front. Then ddx of uv is, first we will keep x as constant, then ddx of tan inverse of x plus keeping second function first and differentiating the first function. So this was my product rule, minus ddx of log x is 1 by x. But again we need to differentiate 1 plus x square due to chain rule. So here this equals to 2x into ddx of tan inverse x is 1 by 1 plus x square plus tan inverse of x, ddx of x is 1 minus, so here ddx of 1 is 0 and ddx of x square is 2x, so we will have 2x over 1 plus x square. Now let us simplify, then we will have 2x by 1 plus x square plus 2 tan inverse of x minus 2x by 1 plus x square. So here this first term and third term will get 0. So my final answer will be 2 tan inverse of x. So this much in this video. So in next video we will be discussing trigonometrical transformation. So keep learning. Bye bye.